In our fifth example here, finding two numbers, the sum of two numbers is 11. The difference of their squares is 143. Find the two numbers. So that's what we need to do, is find the two numbers. And they're very separate. So I'm going to use x and y to represent the two numbers. So the first sentence says the sum. Well, that means if you add them together, is equals 11. Then the second sentence says the difference, which means subtract, of their squares. So that's x squared and y squared. Those are the squares. So the difference of their squares is 143. That sets up two equations here. The first equation is linear. The second equation is quadratic. So in chapter 4, there were systems of linear equations, and there were three ways that we could solve a system. So the first is to graph both of the equations and see what shared points they have. That's a solution. The second was substitution. Solve one equation for one variable, put it into the other equation, and then come back and solve for that one. And then the third was the addition elimination. Okay, so the addition elimination does not work unless both equations are linear. So we can either graph this, which is imprecise and hard to guess, or we'll use substitution. So we'll use the substitution method, and you want to use the linear for the substituted expression. So let me solve for one of these variables in the linear equation. Let's say I want to solve for x. So I'm going to subtract y from both sides. Then x equals 11 minus y. And I don't need these in any specific order. I'd rather have it exactly the way it is. And then I'm going to put 11 minus y in for x in the other equation. So now in the quadratic equation, x squared minus y squared equals 143. So now I only have y in this equation. I can solve for y and then come back and solve for x after that. I'm done with y. So first I need to expand 11 minus y squared. And this is where mistakes tend to happen, so you want to make sure you distribute each term to each term. So you've got 121 minus 11y minus 11y, so minus 22y altogether. And then plus y squared, that's the expansion. Now the rest of the equation, minus y squared equals 143. Okay. So like terms, y squared minus y squared, that's no y squareds. They cancel out. So that leaves 121 minus 22y equals 143. And actually, this is not a quadratic equation. It's a linear equation. So I can solve this by oppositing the number term from both sides. Then negative 22y equals the difference here, which is going to be 22. And then we'll use the multiplication property to multiply the reciprocal, or just divide 22 from both sides. That gets me y equals negative 1. So now I need to come back to x, and that will be 11 minus y, which is negative 1. So 11 plus 1 is 12. Now I think I have the solution to this, finding the two numbers 12 and negative 1. Let's see if this works. So we need to check. Okay. So the sum of two numbers is 11. Let's check. The sum of 12 and negative 1 is 11. Yes. The difference of their squares, so 12 squared is 144. Negative 1 squared is 1, is 143. The difference is 143. Yes. All right, so I know I've got the right numbers. So my conclusion then is the numbers are 12 and -1. That's my conclusion here.